Bright Duty. Every student matters.
A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters. Side by side, let us see what exactly is given to us. The distance traveled by the truck, represented by small s, is given out to be 400 meter in 20 seconds. The time is given to us to be 20 seconds. Find its acceleration. We need to find the acceleration of the truck. Then find the force acting on it if its mass is 7 metric tons. We also need to calculate the force acting on it, and the mass is given to us in the question to be 7 metric tons. Now we have been provided this detail that 1 metric ton equals to 1000 kilograms. So if 1 metric ton is equal to 1000 kilograms, that means 7 metric tons should equal to 7000 kilograms. Now one vital important thing is the truck is starting from rest, and if an object starts from rest, we know that we take its initial velocity represented by small u to be 0. Now we are provided with the initial velocity, the distance traveled and the time. So if I need to calculate the acceleration from here, I can calculate it by using the equation of motion, and that equation of motion is S is equal to ut plus half a t square. This is because of the second equation of motion, which states that S is equal to ut plus half a t square. The distance given to us is 400 meters. Initial velocity is 0. So anything multiplied by 0 will be 0, plus half into a we need to calculate, and the time given to be is 20 seconds. So I'll square it up. Clear? It becomes 400 is equal to half into a into 20 square. If I'll do, I'll get 400. With cancelling it with 2, I'll get 200. So the acceleration, bringing 200 on the other side, I'll get 400 divided by 200, which comes out to be 2 meter per second square. So this is the acceleration with which the truck is moving, right? This was the first part of the question. The second part of the question was to calculate force. Now I know that force is equal to m into a. How come? It was because of Newton's second law of motion. This was the conclusion we draw based on the Newton's second law of motion. Now force I need to calculate. Mass already is given to me in the question to be 7000 kilograms, multiply by acceleration I have just calculated to be 2 meter per second square, which comes out to be 14,000. 14,000 what? What is the SI unit of force? Newton. So force is equal to 14,000 newtons. Got it? So this is how we'll calculate the force and the acceleration based on the details given to us in the question. Clear? Fine. Now let us see the next question. Now in this question, what we are being said is a stone of 1 kilogram is thrown with a velocity of 20 meter per second across the frozen surface of a lake, and it comes to rest after traveling a distance of 50 meter. We have to calculate the force of friction between the stone and the ice. Let us see what exactly is the detail or the information provided to us in the question is the stone of 1 kg. That means the mass m is given to be 1 kilogram. is thrown with this velocity, that means this is the initial velocity which is given to us to be 20 meter per second, right? It comes to rest, means the final velocity represented by small v is assumed to be 0 because it is coming to rest. After traveling a distance is represented by small s, distance is 50 meter. We need to calculate, we need to find the force, the frictional force between the stone and the ice. This force we need to calculate, right? Now to calculate force, we know the formula F is equal to m into A. This m, that is the mass, is given to us in the question, but what about A? A is not given. So we need to find out the value of A first, and for finding that we are provided with this information U, V and S, right? So now what we will do is we will find A by using V square is equal to U square plus 2AS, which was as per third equation of motion. In this equation, we see that V and U and S are given to us in the question. Let us put up the values. V is given out to be 0, U is 20, we will square it up, plus 2 into A we need to calculate, and S is 50. So this comes out to be 400 plus 50 into 2 is 100A. So 100A remaining here, 400 taken on the other side will become minus. The A part remaining here, 100 will take on the other side. This comes out to be 400 upon 100. So cancelling it out, what we will get is the acceleration comes out to be minus 4 meter per second square. The acceleration is in minus, that means the body is retarding, right? Because we see here that initially the stone was thrown with some velocity, and since it is retarding because of the frictional force of the surface of ice, that is why its final velocity comes to rest position or 0. Now this is the acceleration that we have calculated, but we had to calculate the force. So the force formula is F is equal to m into A. Mass given in the question of that stone is 1 kilogram. Acceleration is minus 4 meter per second square. So the force comes out to be minus 4 Newton. Now this minus sign once again represents that the force is in the opposite direction, as it is frictional force which is causing retardation in this stone. Clear? Got it? So the questions are quite simple. What we need to do is to find force. The formula is m into A. The A part, the acceleration part, is not given in the question lot of times. So for that, of course, we will be provided some information, and we need to calculate that acceleration using any of the 3 equations of motion. Depending upon what all details are given, we will apply any one of the 3 equations of motion to find A. The value of A once found out, then we can easily find out the force because mass is given in the question. Clear? This is a simple way of attempting such type of numericals. Let us see a few more examples. Now this is a very good example. This requires a bit of thought process. Let us see how. An 8,000 kilogram engine pulls a train of 5 wagons, each of 2,000 kilograms. Now let us first of all take some representation. Let us see example. This is an engine, right? Now the mass of the engine is given to be 8,000 kilograms, right? Now it is pulling a train of 5 wagons. So let us see, let it be the first wagon, let it be the second wagon, let it be the third wagon, the fourth wagon and the fifth wagon. Let us mark it up. First, second, third, fourth, fifth wagon. The mass of each of them is 2,000 kilogram each. Got it? Fine. Along a horizontal track, if the engine exerts a force of 40,000 Newton. So now let us see the force given to us in the question which is exerted by the engine is 40,000 Newton, and the track offers a frictional force of 5,000 Newton. Now this is quite important. The track is offering a resistance of 5,000. So the frictional force of the track is 5,000 newtons, and because this is a frictional force, it will be opposite. So the resultant force which will be acted upon this particular train, the resultant force will be the net of these two forces, which will come out to be 40,000 Newton, the force applied by the engine, and minus 5,000 frictional force, which comes out to be 35,000 Newton. This is the first part that you need to remember, that you need to relate. Alright, fine. So this is the force which is exerted by the engine. Now this force the engine is exerting on these 5 wagons. So now when we are talking about these 5 wagons, so we need to see what exactly is the force of these 5 wagons. Now the important thing to remember is that this particular information, that the engine is of 8,000 kilograms, it is basically irrelevant. Why? Because the engine is not applying force on itself. It is applying force on these 5 wagons. So while calculating the mass, we will just take the mass of all these 5 wagons. Now the mass of one wagon is 2000. So the total mass of 5 wagons will be equal to 10,000 kilogram. Got it? I repeat, the mass of engine is not to be included. There are times when students think that the value is given, so it also needs to be added up. No. Fine. So now we are provided with force and the mass, and we know that F is equal to m into A as per Newton's second law of motion. Right? Based on this, we see that F upon m will be equal to A. So by this, we calculate the value of acceleration. The force we have calculated to be 35,000 Newton. The total mass was 10,000. So the acceleration is 3.5 meter per second square. This is the acceleration which the engine is imparting to all the 5 wagons. Right? Now let us come back to the question. The first part of the question was asking that we need to calculate the net accelerating force. This is what we have calculated. It is 3.5 meter per second square. The second thing is the acceleration of the train. Now the acceleration of the train will once again be, the whole train is moving with this particular acceleration. The important thing what he is asking is the force of wagon 1 on wagon 2. Now this part you need to relate a bit. Till now we were calculating the force which the engine was providing on the rest of the wagons. But now what we are being asked is we need to calculate the force with which this particular wagon 1, right, is pulling this wagon 2. Now one important main thing that we need to correlate over here is that this particular wagon is also associated with, joined with the rest of the 4 wagons. The way we calculated that the engine was applying force, then we took the engine's force on all these wagons. We had summed up the mass of all the 5 wagons. Similarly, when we are talking about the force by this particular wagon number 1, then we will see that this wagon number 1 will be applying force not on this particular wagon number 2, but this will be all connected. So this is the main important thing we need to remember first. Second thing, Now we know that this particular train or all the wagons are moving with a normal uniform acceleration of 3.5 meter per second square that we have just calculated. So now acceleration is given to us to be 3.5 meter per second square. The mass is what we are going to take is 8,000 kilograms. Why? Because this was the wagon number 1. When it is pulling wagon number 2, the third and the fourth and the fifth wagon, they are all going to be together, because this force which is applicable from wagon number 1, it has to pull all, because they are all joined up, tied up. So the mass will be 8,000 kilograms. Now to calculate the force, simply we need to apply F is equal to m into A because of Newton's second law, and applying the values we get 8,000 multiplied by 3.5, which comes out to be 28,000 Newton. So this is the force which is applied by the first wagon on, to say is on the second wagon, but actually it is a combination of second, third, fourth and fifth wagon, right? So that was the punch point that you need to remember. Normally students tend to make mistake that they just consider that first wagon is going to apply the force on the second wagon. They will just take the mass of second wagon, that is 2000 kilograms, which is not to be taken. Why? I hope you must have understood the actual reason behind it. Got it? Fine. So this was a different and a good question. You must have understood how to calculate it. Fine. Let us see the next question. Now in this question, what the examiner is asking is, an automobile vehicle has a mass of 1500 kilograms. So the mass is given to us. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? We need to find out the force between the road and the vehicle, and of course when we are saying the force between road and vehicle, the two surfaces, it's frictional force, right? Now what all is given to us in the question is, the mass is given to be 1500 kilogram, correct? The vehicle has to be stopped, means in the question V is given to us to be 0. Acceleration is given to us to be minus 1.7 meter per second square. Now we have to calculate the force. We know that force is simply F is equal to m into A. Mass is given to us in the question, A is given to us in the question. So we don't require this information about V is equal to 0. There is no need. We'll just simply multiply the mass, which is given to be 1500. Acceleration is minus 1.7 meter per second square, and we already know the minus sign indicates retardation. It's negative acceleration, right? So now by multiplying it, we'll get the answer to be, it is 2550 newtons in minus, right? Fine. So this is the force acting on this particular automobile vehicle. The force is in minus because it is a frictional force, and this minus sign indicates that it is an opposing force which is actually opposing the direction of motion of the automobile vehicle. Clear to all? Got it? Now next question, let us see. What is the momentum of an object of mass m moving with a velocity v? Quite simple question. We know that the momentum of an object, the formula for momentum is simply mass into velocity, right? So now the formula, the option given to us are mv square. We know it's not mv square, not half mv square, not. This is the actual formula that we know, it is the product of mass and velocity. So D is our correct option, right? Okay. Now let us see the next question. Using a horizontal force of 200 Newton. Horizontal, we know that this is the horizontal and this is the vertical, right? So using a horizontal force of 200 Newton, we intend to move a wooden cabinet across a floor at a constant velocity. Example, let this be a wooden cabinet. Now, I need to apply force of 200 Newton so as to move this wooden block with a constant velocity. What is the friction force that will be exerted on the cabinet? Now, one thing we know, we have already studied that there must be some unbalanced force acting on a particular object to make it move or to change its motion, right, or speed or velocity. Now, let us assume that if the force that we are applying is either equal to or less than the frictional force, then in that case, as per what we have studied earlier, we know that this object is not going to move. So therefore, if we are able to move this wooden cabinet by applying a force of 200 Newton, that means the force of friction has to be less than this 200 Newton. It can't be even equal to 200 Newton. Why? Because had it been equal to 200 Newton, then in that case, both the forces must have been balanced, they must have cancelled each other's effect, and the cabinet would have stayed at its initial position only. So therefore, we can relate that the frictional force needs to be less than 200 Newton if we want to move this cabinet with a constant velocity. Got it? Fine. Now, one thing I would like to add here, students, that you need to practice these questions and understand, because most of the times whenever you see some value given in the question, you are required to calculate some value in the question, you start pondering and thinking about as to which formula I am going to use. So there are many times where no formula is used. It is just your practice, your observation, your presence of mind which will give you the answer, and this is one of the perfect questions which tell you that there is no value to be calculated. There are some students who will first of all try to relate force is equal to F is equal to m into A, will calculate A, then putting the value A will calculate this F. No, it's not. Right? And that is why we do these questions. We practice these questions so that we are very well aware as to what exactly the question is asking, and accordingly we should give the answers without wasting our time thinking about as to how they are done. Okay, thanks.